Hello everyone. What I'd like to do in this short video is go over the solution to 1.1.6s in Broverman's Mathematics of Investment and Credit. So if you're in my course, AMAT 301, I do have the solution up for this, but still, I think it's good to go over, and I would have gone over it in class. But Okay. Joe deposits 10 today and another 30 in 5 years into a fund paying simple interest of 11% per year. So that's pretty straightforward. It's very simple for Joe, no pun intended. Tina will make the same two deposits, but the 10 will be deposited in N years from today, and the 30 will be deposited 2N years from today. Tina's deposits earn an effective annual interest rate of 9.15%. At the end of 10 years, the accumulated amount of Tina's deposits equals the accumulated amount of Joe's deposits. Calculate N. Okay, so this is one of these annoying quadratic formula problems. I've said it. I don't know how many times I've said it if you're in my class. I don't know if I've said it yet, but I'll say it many times. I'll never understand why Exam FM decides to test you on, or wants to test you on, your knowledge of the quadratic formula. I don't think insurance modeling requires a quadratic formula all that much, but whatever. All right, so yeah, let's just get to it. So we have Joe earns simple interest. Okay. So he earns $10 today and $30 in 5 years. So the simple interest rate is 11%. Okay. The accumulated value for Joe after 10 years. Well, so Joe deposits $10 today. So that earns 10 years of simple interest at my simple interest rate of 11%. He deposits 30 in 5 years. So after 10 years, that obviously earns 5 years of interest. So it's 1 plus 0.11 times 5. And add this up, you will get $67.50 after 10 years. Okay. So yeah, so nothing really to Joe. That's very straightforward. So let's now do Tina. And here a time diagram certainly helps. I mean, I guess I'll draw the time diagram quickly for Joe. You don't really need it, but so I don't have to go back. I mean, I don't really need it, but so yeah, it's $10 here and $30 here. So you see the 10 earns 10 years of interest. 30 earns 5 years of interest, all at a simple interest rate of 11%. Okay. Tina earns 9.15% interest, and interest is compounded. It's compound interest. Okay. Okay, so her time diagram is as follows. Right, so this is 10. Okay, so first thing to notice is that if this occurs, so the first deposit is sorry, it's also 10 and also 30. Okay, but the first thing to notice is that this is 10 minus n, the time that this $10 earns interest for. If you deposit at n, then it earns 10 minus n interest for a total of 10 years. On the other hand, if Tina deposits $30 at 2n years, then that $30 is going to earn 10 minus 2n years for a total of 10 years. Okay. Okay, so the accumulated value after 10 years is 10, 1.0915. Again, it earns 10 years of interest at this compound interest, this effective annual interest rate of 9.15%. And then the 30 earns 10 minus 2n years of interest. So yeah, so the problem says that they earn the same. I'll just go back to the problem very quickly. After 10 years, the accumulated accumulated value, same thing, of Tina's equals the accumulated amount of Joe's. We're going to use that to calculate n. So right. So one thing I want to make clear is that actually down a bit, move this up. So for Joe, it says simple interest. So no subtlety there. For Tina, it says the effective annual interest rate is 9.15%. That means we're dealing with compound interest. But otherwise, as I mentioned, unless otherwise stated, we're dealing with compound interest. So this definitely, unless otherwise stated, we're not stating otherwise. But the two things together should make it absolutely crystal clear that we're dealing with compound interest. Okay, so let's go back. So the two accumulated values are the same. So we conclude that Joe's accumulated value is equal to Tina's, both after 10 years. So 67.5 is 10, 1.095, 915, 10 minus n. Smaller here. Up. I should have enough room actually. Plus 30, 1.0915 to the 10 minus 2n. Okay. Okay, so right. So definitely what you want to do is use basic rules of exponents. This is 10, 1.0915 to the 10th times 1.0915 to the minus n. 30, 1.0915 to the 10. (1.0915 to the minus n). Okay. So you could do one of two things. You could just set this. Sorry, that's not right. It's 2n. Actually, yeah, that's 2n. So yeah, you could do one of two things. You could say this whole thing here is x, and then you should recognize that this whole thing here, by the basic rules of exponents, is x squared. And then just solve this quadratic, plop these two into plop these two into a calculator. Or you can actually, that's probably the best thing to do. I think what I decided to do was just get a positive exponent. So multiply both sides by 1.0915 to the 2n. Yeah, it's not really necessary, but you don't have to do that. You could just do what I just said a second ago. But whatever. Doesn't really matter. Both ways are fine. Okay, so right. So, 1 second. Right. So you can also put this in a calculator. If you do that, let me tell you what that's going to be. Do that. So this here is going to be 24.00145. And this here is going to be 72.00434. Okay. So I'm going to multiply both sides by 1.0915 squared. So I get, it's getting all crowded here. So, and it's just because I like positive exponents. But yeah, again, you don't really have to do this. You might find it silly that I did this, but yeah, so I'm taking both sides of this equation, multiplying by 1.0915 to the 2n. Okay, so this equals sorry, 24.01, sorry, 00145 to the 1.0915 to the n. And then this is just 72.00434. Now what I definitely want to do is set this to be x. So this is x squared. So if I bring everything to one side, I will have 67.5x squared minus 24.00145x minus 72.00434 is 0. So x is going to be negative b. So you better, so it's a minus here, minus minus makes it a plus. Plus or minus square root of b squared. So for exam FM, you better have the quadratic formula branded into your brain. B squared minus 4ac. Over 2a. Okay, yeah, and so remember x is going to be what is x? This is x, so this can't be negative. So we exclude the negative solution here because that gives me x is negative. So it's really a plus. Normally it's or yeah. All right, so you get x is 1.22581. Right. Okay, so finally, just a reminder of what x is. So 1.22581 is x is 1.0915 to the n. So just solve for n. I'll trust that you know how to do that. 1.22581 over ln of 1.0915. And that equals 2.32543. All right, so that's your answer. And it's not a bad idea to double check that this is correct. I won't do that, but yeah. So hopefully that was helpful. Not too bad of a problem. A bit, yeah, I don't know if I would call it convoluted. Not sure what exactly it tests you on in terms of understanding financial mathematics, real life financial mathematics, but as I've said many times, I don't write the exam, so not my decision on what's on there and what's not. All right, so long, take care, bye-bye.